All right, hey everybody, welcome to part 2 of Pythagorean theorem lessons, 8.2 and 8.3 out of our textbook. Let's get right to it. Well, if you're wondering why I'm dressed the way I am, I'm about to go to a basketball game. So anyway, I'm ready for that, and not my normal clothes. So anywhere there is a right triangle, the Pythagorean theorem will apply, and then Pythagorean or right triangles occur all over the place. So I split this up to try to make up some of the maybe what I think of as more advanced, of the basic Pythagorean theorem in the first lesson. Here's some more advanced stuff. I don't think it's going to be that crazy for you. Where you have a right angle, you can usually make a right triangle. So rectangles, of course, have right angles. If you draw a single diagonal, it will make right triangles. You actually have two right triangles. And if you have the right triangle, you can use Pythagorean theorem. So you could use this side and the side, or would be the legs, and the hypotenuse is the diagonal of it. So every time you see a rectangle, the right Pythagorean theorem will apply. Now isosceles, this may not be as obvious here at first, but isosceles triangles have right triangles built within them through an altitude. If you have an altitude drawn from the vertex angle to the base of the isosceles triangle, it creates two congruent right triangles. The other thing that it does is it also serves as it's an altitude, it's a median, it's an angle bisector, and a segment bisector down here. It bisects the base. So you'll see that a lot. Foreshadowing here, an example here, this base, which is equal to 10, is going to get split in half. But the key, what I'm trying to say right now, is you end up with right triangles when you draw that altitude. Rhombuses, if you draw those two diagonals, remember what they do in the middle? They are perpendicular, so we end up with four congruent right triangles. Okay? So those are some really, really, really common ways that we'll be seeing right triangles about. So I'll run through these examples. This is, I hope, clearly a rectangle to you now. So this is then, therefore, a right triangle. So we can apply the Pythagorean theorem, 6 squared plus 9 squared equals x squared, and solve. Once we get square root of 17, that does simplify to 3 square root of 13 is the final answer. That's the length of the diagonal. And we'll see some word problems like this too, because you just need, if you understand rectangles, these are the two sides, lengths, and so the diagonal, we can talk about the diagonal. It'll always be the hypotenuse. This is an isosceles triangle with the altitude drawn from the vertex angle. So the right triangle is here. 13 is the hypotenuse. X is a leg of the right triangle. And then this other leg we have to calculate by splitting up the 10 into 5 and 5. So we have 5 squared plus x squared equals 13 squared. Pythagorean triple, 12. Well, we don't know what a triple is. My bad. We will in a minute. On example C, we can figure out all of these sides because they're all congruent, and we have these four congruent right triangles. AC is equal to 12, so the diagonals are bisecting each other. That way we end up with 6 and 6. BD bisects, we end up with 8 and 8. So 6 squared plus 8 squared is equal to x squared. We solve, we get 10. So it's just to use the Pythagorean theorem. All right, so I want you to go ahead and try these. We got a rectangle, isosceles triangle, square, which is a rectangle, isosceles triangle, rhombus. This is none of the above. This is just simply a right triangle stacked on top of a right triangle. So you'll have to apply the Pythagorean theorem twice here. And I'll let you see if you can figure this out. This is a right triangle here, and then another right triangle that helps you to get those. Word type problems, but it's the same as the ones that above. There are, let's see, 12 of these. Give a good try on at least 5 up here, and then 2, or do 3 of these down here, and give those a good shot. Do them all if you want, of course. Did you pause? I hope you did. Here's some answers to 9 through 16. I should be seeing some good work here. Y'all are not ready to do these in your head. I know that for sure. Here's the answers to these. Sorry, something happened. It'll help you to draw these diagrams. Here they are, based on what's given. It talks about the perimeter of a rhombus. Splits it up into congruent pieces. Okay, so these are those answers. All right, Pythagorean triples. You may have noticed that there's some patterns that happen with these. Well, maybe you haven't, but this is what this is about. There are patterns. 3, 4, and 5 is a really common triple of integers, where 3 squared plus 4 squared equals 5 squared. We'll see that a lot. So we call that a Pythagorean triple. But if we multiply, it's a ratio, 3, 4, 5. If we multiply the 3 times 2, the 4 times 2, and the 5 times 2, we get 6, 8, 10, which is another really common one, okay? Then if we multiply by 3, we get 9, 12, and 15, 3 times 3, 4 times 3, 5 times 3, and we can fill up this whole little list of these. Some of these are these are actually all really common. You will have some of these memorized. I'll tell you in class which ones you need to have memorized. It won't be all of these, but what I need you to understand is that these ratios, the 3, 4, 5, the other common one is 5, 12, 13, which helps us get 10, 24, 26, 15, 36, 39, etc. 8, 15, and 17, 7, 24, and 25. And we can complete these. But these ratios, 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25, are ones that you have to know. It's memorization. There's not exactly a pattern involved. We will talk a little bit more about it, but you're going to have to know those patterns. Okay? You'll want to because it makes life easier. Not knowing them will make life hard. We want life to be easy. I do. I want your life to be easy. So, look at these. These questions right down here, 5, 6, 7, 8, if you know these triples, this is a piece of cake. You got 14, 48. Where do you see up here 14 and 48 together? Oh yeah, right there. So 14, 48, and 50 is the triple, the two legs. That gets you 50 from that. Okay? 16, 34. If you know these triples, you know right away 16, 30, and 34 is a triple. And so there are those answers. Okay? We'll talk a lot more about that in the days to come. And finally, this geometric mean thing. We talked about geometric mean real briefly with section 8.0. Remember what a geometric mean is first. A geometric mean is when you have a proportion when the means, actually, or the extremes, are the same number. It's where the means are the same number within the proportion. Becomes the geometric mean of that. This applies to a right triangle like this. We actually saw diagrams like this in Chapter 7. We're going to make life a little bit easier now that we know more things. Here it goes like this. The length of the altitude is the geometric mean between the parts of the hypotenuse. So do you see that A here is the altitude? It goes from the vertex, makes a right angle. The parts that it breaks it up in of this, the hypotenuse, of course, I have marked as H. If I split it up into F and G, well, A is the length of the altitude is the geometric mean between F and G. So you can write this proportion. F over A equals A over G. We could have done this with similar triangles, but this makes it simpler. And if we cross multiply, you get A squared equals FG. So A times A equals F times G is what ends up happening thanks to this theorem. Okay? Also, there's a couple other geometric means that happen. The legs, which are L and M according to my diagram over here, is the geometric mean between the hypotenuse, H, and the part of the hypotenuse adjacent to the leg. So each leg, so we're going to have two different proportions that we can write. Each leg, so here's a proportion where L, this leg, is the geometric mean between the hypotenuse, H, and the part of the hypotenuse adjacent to it. That's F as opposed to G. F is adjacent to L, G is not, so there is your proportion. L squared equals HF. We can do the same thing for M. M is the geometric mean between the hypotenuse and the part of the hypotenuse adjacent to it. Okay? Knowing these will make life easier, kind of like the triples. So that's the lesson part. Let's apply this here now. If we're going to, example 3, solve for x and y. We have a right triangle with an altitude coming from the right angle. Y is the altitude. Okay, so the length of the altitude, y, is the geometric mean between the parts. So y is the geometric mean between 4 and 5. 4 over y equals y over 5. That's the shortcut. So y squared equals 20. Solve for y, 2 squared root of 5. Okay? Also, x is a leg. So it is the geometric mean between the hypotenuse, which is all of 4 and 5 together, 9, and the part of it that's closest to it, 4. So its geometric mean is x squared is equal to 36, so x ends up equaling 6. Okay? So this only applies in a special case with this altitude in the right triangle. Go ahead and see if you can solve for x, y, and z on 9 and 10. Give it a shot. Definitely better be seeing some work on these. There's no way you can do this without the work. That's for sure. That's how I'll know if you've done things you're supposed to be doing, too, by the way. Get some rest. Love you, bye.